Last week we covered the beginnings of nomenclature. We talked about naming ions and writing formulas for ions. There are polyatomic ions, which have more than one atom in them, and then there's monatomic ions. And so we learned about those. Now we're going to learn how to put those ions together into a compound. So an ionic compound has a positive and a negative ion together so that the charges add up to 0. A formula unit is the term we use instead of molecule for ionic compounds, because technically ionic compounds don't have molecules. But a formula unit gives us the simplest relationship between the numbers of ions of each type, the cations and the anions. So important to remember that a formula unit is neutral in charge. The total positive charge must equal the total negative charge. Nature doesn't like when charges are separated. It wants things to be neutral. So you can't have a jar of negative ions without positive ions there to balance the charge. It just doesn't work out well. We use subscripts to indicate the number of each ion in a formula unit. And for ionic compounds, the subscripts must always be the smallest ratio. So we'll look at that, but those are things to keep in mind. So when we write a chemical formula for a compound, we need to look at the formulas for the individual ions. And on the first worksheet that you hopefully started working on in activity session, it's called Ionic Compounds. It asks you to write the formulas for the individual ions. You need the formulas with their charges to be able to see how you need to put them together. So here we've got Cu plus and O2 minus. And what we're doing is we're trying to figure out how many of each of these do we need so that when we put them together, their charges will all add up to 0. If you're a math type person, we're looking for a least common multiple. Pretty sure that's what the math people call it. Copper 1 oxide is the formula, the name for the compound. The first word, copper 1, tells us what the formula for the first ion is. This is copper ion. The Roman numeral 1 tells us that it has a +1 charge. Oxide is an oxygen atom with a charge. We know it's 2- by looking at its position on the periodic table. And so we write these. This is the first step in writing a formula of a compound, is to write the formulas for the ions with their charges. And then we look at those and we figure out how to put them together. Now this is where people are going to think about things in different ways. So I'm going to show you a couple of different ways to think about this. And you need to pick the one that makes the most sense to you and just use that. I'm not going to make you show all these other ways, but I'm going to present several different ways because everybody thinks about stuff a little differently. So one way to do this is we can look at this and say, well, there's +1 and there's -2. That's not going to add up to 0. I'm going to need 2 of these to balance out one of those. And if you're that kind of a person, you'll just look at this and say, well, that must be Cu2O. And that's, you ask the person, well, how did you do that? And they're like, well, I just looked at it and that's what it is, right? So that's probably the minority of students. Another thing you can do is draw pictures. So let's just start with those since they're already written. I'm not going to write it down. And let's just add up, what's the total positive charge?
1.
That's +1. And if we have one of these, what's the total negative charge?
2.
So, yeah, 2 negative, so -2. Those aren't equal. We have a problem. We need them to be equal. We don't really care what they are. We just need them to be equal. So we've got too many negative charges. We can't change the charge on the ion. We can't cut it in half. All we can do is add more of one or the other ion. So this means we want to add one more of those. So I'm going to draw another one. If I had 2 of those, Now what's the total charge? Positive. Plus 2. Okay, now we're talking. We got plus 2 and minus 2. Those are going to add up to 0. Then I'm going to look at what I've got here, and I have 2 of those ions. So I'm going to write the symbol Cu, and I'm going to give it a subscript 2 to indicate that I have 2 of them. I have 1 of this one, and so I don't write a 1. We do not include the charges in the formula for the compound. It would clutter things up. So that's another way to think about it. This is probably the favorite method. It's usually referred to as crisscross. And it works most of the time. It does have a couple of pitfalls. But, you know, in life, something that works most of the time is pretty good, right? So the way you do the crisscross method is you look at the charges, and first you're going to ask yourself, are they equal? We've got plus 1, minus 2. Obviously, they're going to be opposite in sign, but 1 and 2 are not the same number, right? So then we can do crisscross. Crisscross says, I'm going to take the number from this one, and that's going to become the subscript for the other ion. I'm going to take this number, and that's going to become the subscript for the first ion. So Cu2O, and there's the unwritten 1. We didn't write the 1 up here. I'm not going to write the 1 down there because chemists don't like to write the number 1. Did one of those make sense to you? Anybody want to see boxes of bowling balls or little boys and cookies? Maybe later. This is a very important thing to be able to do. You have to be able to do this. So if after I go through all these different explanations and examples, you're still not getting it, please get in contact with me either by email or text message or in person, or talk to Josh, your tutor. Get some help, because this is not hard math, but it's kind of weird, and so you got to get around the weirdness thing, and then you'll be fine. So you just need to work through it. The light bulb will come on, and then you'll say, oh, it's easy. It's not going to necessarily look easy at first. Let's do another one. So write the chemical formula for cadmium oxide. Well, we first need the symbol for, or the formula for the ion. So here's cadmium. And how do we know that cadmium has a plus 2 charge? There's no Roman numeral on that one. We look at the periodic table, bless you. Cadmium is in that triangle, right? The aluminum, zinc, silver in the triangle. It's under zinc. It has a plus 2 charge. And here we have our friend oxide. We run into him, well, her, I should say. We run into her a lot. So here we have cadmium and oxide. Look at the charges, plus 2 and minus 2. If I just put those two together, will their charges add up to 0? Yeah. So we don't want to do anything fancy here. We just shove them together and we write CD capital O. There's the formula. You don't want to do crisscross here, because then you'll end up with CD2O2. And we want the lowest ratio for ionic compounds. Any questions? Let's do this one down here. Cobalt-3 oxide. So there's oxide. We've seen her twice before now. Here's cobalt-3. The Roman numeral tells us it's got a 3 plus charge. What method would you like me to do first? Crisscross or drawing pictures? Crisscross. Okay. So we're going to look at this. We see we got plus 3, minus 2. Not the same numbers. That tells us we could do a crisscross thing. So I'm going to take this 3, and that's going to become the subscript for the oxygen. 2 becomes the subscript for the cobalt. CO2, CO2O3. Very important to make your big O's big and your little O's little. Any questions? Let's do the drawing pictures. So CO3 plus, it's not really pictures, I don't know why I call it that. And so we're going to add up, we've got plus 3 from that one and minus 2 from this one. So we have more positive charges and not enough negative charges. So we'll draw another oxide. Then we need to adjust our total. Now we have negative 4. Negative 2 plus negative 2, negative 4. Well, now we've tipped it in the other direction. We have too many negative charges and not enough positive charges. So what can we do? We need to add another cobalt, right? That's all we can do. Add a cobalt. And now we're going to get plus 6 over there. And at this point you think, good grief, we're going around in circles, right? Now we've got too many positive charges. Let's just keep going. Let's add another oxide. Now 3 oxides give us a total of negative 6. Oops. Oh, please come back. Please. Ooh. I've been having quarrels with my iPad lately. He's winning. So these add up to minus 6. This adds up to plus 6. Count them. 2 of the COs, so I put the subscript 2. I've got 3 of these guys, so I need a subscript 3. This is a more visual method of seeing what's going on. The math way is to look at these two. You've got 2 and 3, and you will want to find the smallest number that has 2 and 3 as factors. 6 has factors of 2 and 3, and so that's how we end up with the charge of 6 here. That'll make sense to a few of you. If it doesn't, just say, plug your ears and say, la, 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 la. Any questions? A comment I frequently get about this stuff is students will say, but it looks so easy when you did it in lecture. It's my job to make it look easy. I've been doing this for years. If this wasn't easy, I'd be in the wrong line of work. It's not going to be easy the first time you try to do it on your own, but don't give up. You're going to have to do some practice, and then it will become easy, but you may have to put some work in. What if we have polyatomic ions? When we have more than one polyatomic ion in a formula, we put parentheses around it. I talked to you about this, I believe I talked about shrink wrapping things at bundle packs from Costco, right? So here's an example. NH4 2SO4. The parentheses are here to tell us that we have 2 of everything inside. So the bundle pack is 1 nitrogen, 4 hydrogens. That is a package. And outside the parentheses, the number 2 says we have 2 packages. Or you could think of this as being like a car. There's the body of the car and it has 4 wheels. So if I have 2 cars, how many wheels do I have? 8 wheels. And if I have 2 cars, how many bodies of cars do I have? 2, right? So that's what this is doing. If we don't have the parentheses, then it looks a bit confusing. Come on, let me draw on you. NH4 2SO4. That looks like 1 nitrogen and 42 hydrogens, right? That's not what we meant. We put the parentheses in there. Okay, it's a little bit like math, where if you have 2 times x plus 5 or something, the 2 multiplies everything inside the parentheses. Make that go away. And if we look at where this one came from, where this formula came from, what's the charge on ammonium ion? +1. Somebody's been using flashcards. What's the charge on sulfate ion? 2 minus. So looking at the charges on these ions, we need 2 of the NH4s to balance the charge on one SO4. And that's why this is the formula for the compound. Do not use parentheses for monatomic ions or for a single polyatomic ion. Sulfate is a polyatomic ion. We have a polyatomic ion in here. There's only one. We don't need parentheses because nothing's confusing. The way I remember some of this stuff is the system of writing formulas and names was designed to be very concise. We're not going to write a bunch of extra stuff. We're just going to write what is absolutely necessary. And we're going to be really consistent so that everybody comes up with the same formula. We always write the positive ion first and then the negative ion. So there's no SO4 NH4 2. That's backwards. We might understand what you mean, but it looks funny. It's not what we do. And this is one of the things I like. I like math because usually there's one right answer, right? There's no debating, oh, well, maybe it's 3 or maybe it's 4. No, 2 plus 2 is 4. There's an answer. I like that. Nomenclature. There's an answer. It's either correct or it's not correct. I like that. Okay. Some more examples. And what I'm doing in these examples here is I've already written the formulas for the ions. We did that already. So it just makes things go a little faster here. So write chemical formulas for these compounds. Copper 2 permanganate. This is the copper 2 ion, Cu2 plus. The Roman numeral tells us it's a +2. Permanganate, the way we know that is we memorize it. Okay, it's MnO4 minus. It's possible that you might see some examples in here that are not on the list. That PowerPoint slide that says memorize these ions. Those are the ones you have to memorize. One of the previous instructors for this class made his students memorize some other ions as well, and I decided I'm just going to stick with what's in the book. If you guys can memorize those and learn how to use those, you're going to be fine. Those other few, you can memorize those when you get to 1A. You've got to have something to learn over there. So what is going to be the formula when we put these two ions together? Oops. Yeah, Cu, and then we need 2 of the permanganate ions. Because we have more than one, we have to put it in parentheses. One way you could come up with that is the crisscross. This 2 comes down to be the subscript for permanganate, and the unwritten 1 comes down for copper. Any questions? How about iron 3 carbonate? Here's the formula for iron 3. Here's the formula for carbonate ion. How do we put those together so their charges add up to 0? Can I do crisscross? Yeah, I could because I've got 3 and 2. They're not the same. So if I'm going to do crisscross, then the charge on the other ion becomes the subscript for the first one. The charge on the second becomes the subscript. And then for CO3, I'm going to have the subscript of 3, and so I put that on the outside of the parentheses. How about potassium dichromate? Yeah, K2, Cr2O7. I don't need any parentheses in this one. When I have more than one of a monatomic ion, there's no confusion. So I'm not going to add parentheses and write extra junk. Here, Cr2O7, I only have one of them. Again, leaving parentheses out doesn't make anything more confusing about that, so we don't need the parentheses. Any questions? Why does the plus and the minus go away? That's a good question. Well, I've got a K plus and a K plus, right? And so total charge from them is +2. And then I have Cr2O7, that has a 2 minus charge. So the overall negative charge is -2. If I add these together, it adds up to 0. That will always happen for a compound. It combines in a way that the charges add up to 0. So I don't need to put the charges in here. That would clutter things up and make it look really messy, for one thing. But we understand what the charges are, and so they also don't need to be put in for that reason. Does that help? Kind of?
So does potassium stay positive or does it turn negative?
It still has a positive charge.
They just cancel
They
out?
just cancel out. So the potassium is still positive. Each of them is +1. The dichromate still altogether has a -2 charge. Those are attracted to each other in much the same way that magnets are attracted. The positive and negative opposites attract. So you can imagine magnets, like, have you ever played with magnetics? The little balls and sticks, and they're magnetic, and they go click, and they stick together all by themselves. It's almost like magic. It's magnetism. You can think of cations and anions like magnets, and they're going to go stick and stick together. And they're going to combine in ratios. Great, an airplane on top of the trains. We're going to have a bus come by or something? Trains, planes, and automobiles. Cars honking, maybe. And who needs squirrels? There's airplanes. They retain their charges, but when we put them together, we don't show the charge in the formula. Nothing has happened to their charges. They're still there, but we're not going to show them in the formula. Okay? Anybody else? Another section.